Up to this point in Algebra 2, you have learned how to factor in order to solve a quadratic equation. And in the last lesson, we have learned that there's times when factoring will not work to solve, and you'll need some other method in order to do that. In the last lesson, we learned how to use a method called completing the square. But we learned as well that there are times when completing the square can be a real pain to use because of all the fractions. So I'm going to show you today a method that will always work. You can always use this even instead of factoring, instead of completing the square, and that is a method called the quadratic formula. Now before I get into this, take note that yes, this will work every time, but this may be more tedious at times than factoring. Factoring is probably the easiest one to use if you can pick up on the factoring right away. Completing the square, there are times when that method is not too bad as well. But quadratic formula will always work, but there are times when it may not be the easiest or most efficient solution. But before I get into how to use the formula, I need to show you where the formula comes from. And if you don't follow quite every detail of what I'm saying, that's not the end of the world. You at least need to know how to use the formula. But it is helpful to be aware of the fact that this formula does not come out of thin air, but it actually came from somewhere. Okay, so I'm going to walk you through how to get the formula, and then later I'll show you how to use the formula. So the formula comes from completing the square, where if we have a general equation such as ax squared plus bx plus c equals 0, what I can do is I can complete the square on this general form of the quadratic equation to come up with the formula. So a, b, and c are just any number, okay? And so what I want to do to complete the square is I need to get rid of this coefficient with the x squared term and then subtract c over the constant to the right side. So to get rid of this coefficient, remember I just simply divided everything by that coefficient. So I divide everything by a. So I do that, and now I have 1x squared equals b over a times x plus c over a, and then 0 divided by a would just be 0. And then I need to get this constant term, the c over a, over to the right side. And I do that by subtracting that over. When I subtract it over from both sides, this will cancel. I now have x squared plus b over ax plus something equals negative c over a. Now remember, I need to add something here and here to force the left side to be a perfect square. Well, what do we add there? Well, all I do is I take this number, b over a, whatever that's going to be, I take half of that and then square it. So half of b over a would be the same thing as multiplying by 1 over 2, which would just be b over 2a. And then I have to square that to get b squared over 4a squared. So that's what I have. I'm going to have a b squared over 4a squared. And you don't have to actually multiply it out and square it because we're going to factor back down anyway. But you can if you want. And on the left side, this can factor. Okay, we can factor this, and we factor by putting in parentheses x plus, and then it's going to be this quantity that's being squared. That's how we factor. So we have x plus b over 2a squared equals, and then negative c over a plus, and if I square b, I get b squared. I square the 2a to get 4a squared. Okay, so now I'd like to combine this right side into one fraction. So to do that, I need a common denominator, which would be 4a squared. So the common denominator is 4a squared, and so to get from a to 4a squared, what I had to do was multiply by a 4 and an a, which I must also do to the numerator. Multiply that c by a 4 times a. And now I can combine like terms by adding the numerators. So I have negative 4ac plus b squared for the numerator. Okay, so now picking up where I left off, I'm going to take the square root of both sides to get rid of the squared. So when I do that, take the square root of this side, the square and the square root will cancel. And now on the right side I have the square root of all of this. Okay? Well then, to get x by itself, I need to subtract this b over 2a to the right side. I can subtract that over, so I get negative b over 2a plus, and actually this should be a plus or minus, and then the square root of all of this can break apart into two radicals, the square root of negative 4ac plus b squared over the square root of 4a squared. Well, the square root of 4a squared would be simply 2a. The square root of 4 is 2, the square root of a squared is a, so I have all of that over 2a. And once again, this should be a minus sign as well. So then I can combine these fractions into one, so I get negative b plus or minus, and then I just switch the b squared and the minus 4ac inside of the radical, so the b squared term comes first. So I have b squared and then minus 4ac, and then that's all going to be over 2a. And we've done it. We've solved for x. So this here is what we call the quadratic formula. So that is where it came from, and now we need to know how to use it. So when you use this, we need to get an equation into this format first, where you have ax squared plus bx plus c equals 0, where a, b, and c are just numbers. Once it's in this format, all I do is I take a, b, and c, whatever those numbers are, and plug it into this formula. So for example, here we have x squared minus 10x plus 16. So it's already set equal to 0. I have the x squared term first, the x to the first power term second, and the number third by itself. And a, b, and c would be the numbers with each of these terms. So a would be the 1, b would be negative 10, c would be 16. And all I do is I plug those numbers into this formula, where in place of the b, I put in negative 10. So I have negative or minus a negative 10 becomes a positive 10, plus or minus the square root of b squared, so I have negative 10 squared, minus 4 times a was 1, so plug a 1 in. In place of c, I put a 16, so 1 times 16. And down in the denominator, I have 2 times a, which in this case is 2 times 1. So from here, I just simplify, and I'm done. But be careful when you simplify that you don't make careless mistakes. And when I first learned this, my mistake was order of operations inside of the radical. Okay, make sure you do order of operations first, where you could do exponents, and multiply and divide, and then subtract. So here, negative 10 squared, I can do that first, so I get 100, and then I multiply the 4 times 1 times 16 to get 64. And subtraction right here, I do that after I square and after I multiply because of order of operations. So then 100 minus 64 would give you 36, and then the square root of 36 would be 6. So what I have is 10 plus or minus 6 over 2, which can give me two answers, where I have 10 plus 6 over 2, which would be 16 over 2, or 10 minus 6 over 2, which would be 4 over 2. 16 over 2 is 8, 4 over 2 is 2, so my solution would be 8, or it could be 2. Now notice, yes, in this example, factoring would work. Okay, factoring, you could factor and get x minus 8 times x minus 2 equals 0. Set each part equal to 0. And we get x equals 8, x equals 2. So notice, the quadratic formula will always get you the correct solution, but if you can factor, factoring is much easier, much quicker if you can do it. Okay, but if you don't know how to do that, we do have this method as a backup. Here's another example where you have 2x squared minus 3x plus 7. And this example, the factoring would not work. Completing the square would be a real pain because we have fractions. We will have fractions. So in this case, quadratic formula would be our best method for solving. And what you do is you find a, b, and c. A is the number with the squared term, which is going to be the 2. B is the negative 3, which is with the x term. And then the 7 is going to be your c. By the way, it's just the number, not the x squared. I've seen many people before include the x squared with a, b, and c, and they'll get some weird answer when they finish. So take note, it is just the number by itself. Okay, and then from here, all I do is plug this into the formula, and then I simplify as necessary. So negative b, we have a negative, then minus 3, or minus a negative 3, which becomes a positive 3. And then b squared would be negative 3 squared. 4 times a times c would be 4 times 2 times 7. And then 2 times a would be 2 times 2. So simplify, we take negative 3 squared to get 9. And then 4 times 2 times 7 would give you 56. You can subtract 9 minus 56 to get negative 47. And simplify by getting rid of the negative in the radical. So to get rid of the negative in the radical, I can break it up into 2 radicals, where I have the square root of negative 1 times the square root of 47, and the square root of negative 1 is just going to be I. So we see here our solution is going to be 3 plus or minus I times the square root of 47. Now there are times when your equation may not be in the correct format, and you need to rearrange first if necessary. So to rearrange, what I want is the x squared term first, the x term second, and then the constant term third, and then set equal to 0. So notice it is already set equal to 0, but I need to rearrange this so that terms are in descending order. And also too, I like the x squared term to be positive. Okay, so make the x squared term positive and in descending order. So to do that, what I'd like to do is bring, rearrange this. I get negative 4x squared, and then negative 7x, and then plus 5 equals 0. But I want this to be positive 4x squared. So what I can do is just divide everything by negative 1. Negative 1, so now I have a positive 4x squared plus 7x minus 5 equals 0. So basically I just change the sign of everything. And then here I have a would be this part with the x squared term, which is 4. B would be with the x term, which is 7. And then c is the constant, which would be negative 5. And then from there we can solve if we wanted. Here is one last example, where once again we need to rearrange first so that everything is set equal to 0 and that everything is in descending order. So to do that, I need to get rid of this 4 and negative 2x, bring it over to the left side so that the right side is equal to 0. So if I subtract 4 from both sides and add 2x to both sides, then I'm going to have 0 on the right side, and the right side I'd have, or left side I'd have x squared plus 2x minus 4, and then equal to 0. And so from here, notice this would not factor. Completing the square would be a decent solution or method to solve, but we're working with quadratic formula, so we'll show you how to do it with quadratic formula in this example. So for quadratic formula, we need to know what a, b, and c are. A is going to be a 1, b would be a 2, and then c would be a negative 4. So plug that into your formula, which you should have memorized, and we're going to get, instead of negative b, we have negative 2. Instead of b squared, we have 2 squared. Instead of 4 times a times c, we have 4 times 1 times negative 4. And instead of 2 times a, we have 2 times 1. So now just simplify. 2 squared is 4. 4 times 1 times negative 4 is negative 16. So we have minus a negative 16, which is a plus 16. And then 2 times 1 is just 2. 4 plus 16 is 20. And then simplify as needed. Here we have the square root of 20, which can break down to be a product of 2 times 2 times 5. We can pull out a group of 2's. We have one group of 2, so we pull out 1, 2. We're left with a 5 on the inside. So we have negative 2 plus or minus 2 square root of 5 over 2. But notice every term you can divide by 2, which leaves me with a 1, 1, and 1. So my solution would be negative 1 plus or minus the square root of 5. And I'll just take note, if you are going to simplify, make sure you divide every term by that number and not just, a 2 and a 2. Make sure you do it for all 3 2's in this case.